Welcome to 2.2 Journal Vocab Notes and Practice, page 41 to 43. A lot of basics in here that we use in the course. Conjecture. You can find a lot of this on page 76 in your book. And let's get these in here. It starts on 76. Conjecture is an unproven statement based on observation. We'll look at that a little closer in one of the examples. Inductive reasoning. Inductive reasoning, a conjecture based on patterns. Okay. A counterexample is something that disproves a conjecture. These are really important. Remember, it only takes one counterexample to prove something wrong. Somebody may have 100 examples why something works. If you have one example to prove it wrong, that contradicts the argument. Deductive reasoning, different than inductive. Inductive is based on patterns. Deductive uses facts, definitions. My hand's blocking the rest of this. Accepted properties, logic laws to form a logical argument. We don't call it a conjecture that often because it's not based on observations. You can see some of those ideas right down here. They go over them again. Inductive reasoning is based on patterns. It's not proven. That's important to remember. Again, counterexamples. Why aren't we moving here? Got to mess with this a little bit. So to prove a conjecture, we have to use deductive reasoning. To show it's false, we just need, again, one counterexample. It doesn't matter if somebody's got 1,000,000 examples that it works. If we got one counterexample that shows it wrong, that's it. Remember, a counterexample agrees with the hypothesis, okay, and it disagrees with the conclusion. So you got to agree with the hypothesis, disagree with the conclusion. That's a counterexample. If it doesn't agree with the hypothesis, it's not a counterexample. Deductive reasoning, I mentioned, is the basis of this course. We're not going to do as much with this as we normally would. A couple of things we do use, the laws of these logic here. I'm not going to say they're not asked about. I'm going to ask about them this year. Law of detachment. If the hypothesis of a true conditional statement is true, the conclusion is also true. What I got written real sloppy down there is that's true for all geometric rules. All geometric rules. The law of detachments. If the hypothesis is true, then the conclusion is true. The law of syllogism. If the hypothesis P, then conclusion Q. Another statement, if the hypothesis Q, then the conclusion R. This leads to if P is true, then R is true. If the hypothesis P, then the conclusion R. We got the notation over here. Remember, this means if P, then Q. If Q, then R. So notice this Q is the endpoint for the red one. It's the starting point for the blue one. If I were to, so we can kind of put these together. They're kind of overlapping there. So this ends up meaning, well, hey, if I get Q, then I know I get R. We can bring this just down to our shortcut. If we have P, then we know R is true. That's sort of the idea of the proof. Get the starting point, get the end point. Hey, once we showed all the work in the middle, we can ignore that in the future. I want to unzip this over here. Examples here. So sorry, kiddos, no scrambled answers. They're a little long to write. They're a little too easy to give away. Read your directions, describe the pattern, then write or draw the next two numbers, letters, or figures. Okay, 20, 19, 17, 14, 10. This goes down 1, then down 1 more each time. 20 to 19 is down 1. 19 to 17 is down 2. 17 to 14 is down 3. 14 to 10 is down 4. So the next one's going to go down 5. That'll go to 5. The next one's going to go down 6. That'll go to -1. So 5 and -1 are my next numbers there. So those would be my answers. Two patterns over here. The first one is I'm alternating signs. Positive, negative, positive, negative, positive. The next thing I notice here is these are prime numbers. So I'm just going through primes. So after 7, the next prime number is 13. That's going to be negative because the one before it was positive. The next one will be positive after 13. 14's not prime, 15's not prime, 16's not prime, 17's prime. So that'll be positive 17. There's our answers. Number 3, I'll give you a hint. This is the alphabet. C, D, E, F, G, H. What's going on there? Catch the pattern there. Number 4, I think you can get on your own. So number 5 and 6, make and test a conjecture about the given quantity. Well, some of the testing we actually do beforehand. Remember, a conjecture is based on observation. Okay, so if you don't have an idea right away, the sum of two negative numbers, two negative integers, check it out. -2 plus -3, that gives me -5. -1 plus -7, that gives me -8. -24 plus -17, that gives me -41. You know what? Every one of these added up to a negative. So my conjecture would be the sum of two negative, yeah, it's bad writing. Two negatives is a negative. And that's my conjecture for that one. Now that I think about it, I could have done even better on this one. It's not just a negative. It's a negative integer. Because they're not negative fractions, they're not negative decimals, they're negative intervals. Number 6, I actually got a different answer than the book has, so that you can come up with more than one of these. I should erase this stuff. I should erase all this stuff here. The product of 3 consecutive non-zero integers. So just again, write out 3 consecutive non-zero integers. You can do 2 times 3 times 4. What does that equal? You can do -7 times -6 times -5. Might have to get your calculator out, but you can do that one. What does that equal? Pick another one, try it out, see if you can make an observation. Like I said, I got a different answer than the book did. So there's more than one thing you can notice there. Number 7 here. If n is a rational number, then n squared is always less than n. Let's check it out. Let's say n equals 4. Then n squared is going to be 4 squared, which is 16. They're saying n squared is always going to be less than n. That's going to be false. You put in the numbers we have, 16 is not less than 4. So that's a counterexample that proved that's wrong. There are numbers that this works for. I've tried negative ones. It's false. N equals -3. N squared equals 9. -3 squared is 9. And again, 9 is not less than -3. So my n squared is not less than n. Where this works is with fractions. Okay? So if I had n equals 1/2, n squared would be 1/2 squared, which is 1/4. In this case, 1/4 is less than 1/2. That wouldn't be a counterexample. But this is my counterexample over here for that one. Number 8, just think about it. There's my plane. I got a line intersecting the plane. Does it have to intersect at a right angle, or can it be something different? If it's something different, can be something different, draw it. You're going to be the exact same as this, but your line's going to look a little different. I don't even know what this chunk is. A triangle has, okay, number 9 and 10, law of detachment to determine what you can conclude about the given information. So the law of attachment, if P, then Q. If we have the P, we know Q is true. Okay? If we don't have the P, we can't be sure about Q. If a triangle has equal side lengths, then each interior angle measures 60. Triangle ABC has equal side lengths. Well, that matches this. If a triangle has equal side lengths, so we got triangle ABC has those equal side lengths, then each interior angle measures 60. So we know, what can you conclude? Then each interior angle measures 60 degrees in triangle ABC. I do need to connect this to triangle ABC. Oops, I thought I paused this. Sorry. Sorry about that. On number 10, notice here that there's our P part. Here's our Q part. This matches up with the Q part down here, so we can't make any conclusions. It's got to match the P part. Last one here. We just got a little time left. Again, I don't know why these are written up here. I should be erasing this stuff a hand. Again, this is what I showed you before. If P, then Q. If Q, then R, or whatever it happens to be. You connect these. If P, then Q. Here's the Q. There's the R. So we're basically just going to drop these parts. Let's go. So this is going to be if it does not rain, then, whoops, right much, then I will wear my walking shoes. And I'm out of time. This is going to end.